Okay, now I'm recording. A water heater is connected to a 240 volt AC line that has a resistance of 34 ohm. What is the average power used? Okay, so identify what kind of circuit is this. Say, okay, so this one only has a water heater, okay, with this resistance. So there's no other things, no other component around. So this is a pure resistor circuit. Okay, pure resistor circuit. Yeah, pure resistor. So what I can say is this is a 240 volt AC line. So this one actually is the source. Yeah, not mentioned. Yeah, this one not mentioned. What is it? So is it peak value or root mean square value? Yeah. If not mentioned, yeah, then it's definitely root mean square value. Okay. So is if not mentioned, this one is definitely root mean square value. Yeah, not peak value. It should be root mean square value. So, and one more thing, this one is source actually. Yeah, VRMS source. This one is VRMS source for source. Okay. However, because this is a pure resistor circuit, so it definitely is. Okay, let me draw it out the circuit. So pure resistor circuit. So this is V source, and this is the VR. So since this is a pure resistor circuit, so what I can say is the V source is equal to VR. V source equal to VR. VRMS source. V source is equal to VRMS R. VRMS R, yeah, equal. They're equal, yeah. So okay, and then this is the resistance. Okay, resistance value. So what is the average power use? Average power use. So question A, 8A. So average power. To find average power, normally we just take, you know, because this one got voltage and resistor, so we just use the formula VRMS R square over R, V square over R. You know that? V square over R. Okay. So, however, because this is a pure resistor circuit, so the V source actually equal to VR. Give us the V source. So this V source actually equal to VR. So it's actually equal to, you can change this VRMS R into VRMS source. Over R. Understand? You can change it from R to source. This is only for pure resistor circuit. Which the VRMS source equal to VRMS R. For let's say for RC, RL, RCL circuit, then be careful. The V source is not equal to VR. In fact, their V source is equal to, got those Pythagoras thing, yeah, VL minus VC square plus VR square, and so forth. So that one, the VR cannot change to V source. Yeah, for RCL circuit, all this circuit, they cannot change from VR to V source. Yeah, for this circuit cannot change from VR to V source. But for pure resistor, the VR can change to V source because V source equal to VR, because that's the only component in the resistor, is the only component in pure resistor circuit. Understand? That this one cannot, RCL circuit cannot, V source cannot change to VR. Okay, this one can change to V source. Okay, so just calculate. So this one is 240 square over resistor is 34. Okay, so calculate. So what do you get? Let's calculate. Okay, so the answer is 1694.12, yeah, 12 watt. Okay, so that's it. 694.12 watt. That's the average power. And then question B. All right. So what are the maximum and minimum values of the instantaneous power? Okay, what's the maximum and minimum values of instantaneous power? Okay, so for this, okay, so remember the equations that you learn. Okay, so let's look at the that you have learned about the power. This is a pure resistor, right? Pure resistor, pure pure resistor circuit. So the formula for current, because current and voltage, they are in phase, sine. So instantaneous power, I naught sine omega t multiply V naught sine omega t, you get I naught V naught sine square omega t, and the power is P naught sine square omega t. So the maximum power is P naught, see that, which is I naught V naught. Okay, so based on the formula, P equal to P naught sine square omega t. This is for pure resistor. So you can see the maximum power is P naught. In fact, P naught is actually I naught V naught. Okay, but for this one is resistor lah, source, P naught source. In fact, this one also V naught R, because pure resistor, the V naught source equal to V naught R. Okay, so do I have the P naught, I naught, V naught? Do I have the I naught? I don't have I naught, but I have V naught. Yeah, just use you can also just change it to V naught R square over R. Okay, P naught means use V naught. Instead of VRMS, use V naught or P naught. Okay, so so what's the value? V naught. I have to find the V naught R first. Okay, so V naught R. So I have VRMS R equal to V naught R over cert2. Okay, VRMS R equal to V naught R over cert2. So V naught R multiply VRMS. What is a VRMS? 240 lah. 240 multiply cert2. So what's the answer? 240 multiply cert2. 240 multiply cert2. So the answer is 339.41 volt. 339.41 volt. Okay. So which is 339.41 square over V naught R, which is 339.41 square divided by resistor. What is the resistor? 34. So square divided by 34. So the answer is 3388.24 watt. In fact, actually is okay. Actually, you know that power average is half of P naught. Half of P naught, because based on the half of the P naught, So P average is half P naught. So in fact, you can find P naught straight away. P naught is actually 2 times power average, which is 2 times 1694.12. So you still get the same answer. You still get the same answer. Okay, based on the graph, you see, because it's the center, P naught and half P naught is P average. Okay. Okay, and then P minimum is 0 lah, because it can go to 0. See that? The you know, if you look at the formula, the maximum value, maximum is P naught, and then if minimum is 0, because the graph is, going up and down, up and down, up and down, up and down, between P naught and 0. Okay, so minimum is 0. Okay, so the power minimum. So this is a power maximum. Yeah, and then power minimum is 0. Okay, power minimum is 0. Power maximum, and this is power minimum is 0. Okay, so that's all for the minimum power of the instantaneous power, maximum power. Okay, so that's all for this question. Okay, bye.